Yeah, hi everybody. Welcome to Neonatal Testing Best Practices, where we're going to be discussing neonatal testing for the next 55 minutes or so. So as Katya mentioned earlier, my name is Michael Rach, and I'm the Portfolio Manager for Fluke Biomedical. And I'm really excited to get into today's content. So let's jump right into the outline of what we're going to cover today. So we're going to start off with a bit of background information to understand the basics of incubators and how they work. We'll then jump into the importance of testing, including global testing standards. And then we'll spend the majority of our time talking about some best practices for incubator testing, both at a very high level and some that are quite detailed. And finally, we'll wrap it up and tie everything together in a review. And we'll end the webinar with questions from the audience. So that's what we're going to cover today. And to start, we want to jump into today's first poll question. So were you or do you know someone who has been in an infant incubator? Just a yes or no question to get a sense for where everyone's at. And while we wait for answers, I'll share a little story that 2 out of my 3 children have been in an incubator right after they were born. I had twin boys and they were about 4 weeks premature. And one of them stayed 9 days, the other 22 days in the NICU. So in general, I'm very thankful for all the nurses and equipment that really helped my boys become the thriving 5-year-olds that they are today. So for me, I would definitely say yes here.
Okay, Mike, thanks for sharing that with us. And I'm actually going to close the poll now and share the results. And let's see, we have 76%, yeah, impressive, indicated yes, and 24% indicated no.
Oh, that's great. So I'll actually jump to the next slide to kind of answer that question. And it's really good that 76% of you have experienced this in some way, shape, or form, because it is a common occurrence, a common use case. But let's start off by getting an idea of the patients that are actually using these incubators. According to the World Health Organization, more than 140 million babies are born worldwide each year. And while welcoming new life into the world is a wonderful and awe-inspiring event, sometimes things don't always go as planned, like in my case. About 1 in 9 babies are born premature, and many more are born with illnesses or are injured due to complications after or during birth. Premature births and complications are relatively common, and like we saw, 76% of you have either been in an incubator or know someone or a loved one who has been in one. So these small patients are especially vulnerable for the first several days or even months of life. And it's really important that we make sure that these are maintained. So one thing I want to cite is an article in the October-December 2018 Journal of Clinical Engineering that discussed infant incubator testing. It was called A Study on the Performance and Safety Test of Infant Incubator Devices, and it reviewed how an incubator worked and how to test it. They had an investigation in there of 50 infant incubators across 10 hospitals, and they found several faults, both in terms of safety and functional faults. So we have a common use case, we have something that's used regularly, and we have an evidence of faults. So it's definitely warrants digging in a bit deeper, which is what we're going to do today. So on the next slide, I want to kind of jump into the basics a bit. So you have these premature, injured, or ill infants that are placed into an incubator. And this is vitally important to the well-being and care of these babies. What an infant incubator is a fully enclosed box-like structure that carefully controls its environment to protect infants during their earliest stages of life when they're the most vulnerable. The FDA classifies these incubators as Class 2 medical devices, meaning they're higher risk devices than Class 1 and require greater regulatory controls to provide reasonable assurance of the device's safety and effectiveness. So they do this by modulating temperature, humidity, airflow, sound, and oxygen, oftentimes with CO2 levels. And incubators really seek to replicate the haven of a mother's womb as much as possible, and to create a safe environment for premature and very ill babies to grow, heal, and develop. So with that, I want to jump into a brief overview of how incubators work. So the incubator may include an AC-powered heater, a water container to add humidity, a motorized fan to circulate the warm and humid air throughout the cabin, a control valve through which oxygen may be added, and a servo control to help regulate air temperature. This is a temperature sensing thermistor that's usually taped to the infant's abdomen. There's also hand access ports with doors, and that limits the introduction of cooler air while the infant is being handled. And there's a hood or side panel that can be opened to gain greater access to the infant. The heat circulated in the cabin is then absorbed into the baby's body by blood convection and tissue conduction, ideally keeping both the skin and core temperature maintained by minor variations. So you really don't want the baby to change much. The mattress can also double as a weighing scale. So as the process of weighing these fragile and sick little infants is often trying and can be a time-consuming task for the nurses, it's helpful to have that built in. And this can also be detrimental to the patients, since you want to limit the contact to these infants as much as possible. So that's kind of a brief look at what infant incubators are and how they're kind of built up. So for that, after that brief introduction, I wanted to toss it over to Katya to kick off poll question number 2.
Thank you, Michael. Yeah, let's move on to the next poll question, just to get a feel of how many in the audience have heard of the concept of STC, steady temperature condition. So the question is, what does it refer to? Option A, the moment an incubator hits its temperature set point. Option B, when an incubator stays within 1 degree Celsius of its set point for an hour. And if you're not sure, please choose option C. So let's launch the poll and see what the results are.
Okay.
All right, let's
yeah.
run it for a few minutes. Well, a second, I guess.
Okay. And I'll give the audience about another 5 seconds to enter their response, because I know we have quite a bit of information that we want to share today. And the poll is now closing. I'll share the results.
Very well. Okay, that is very good. So we're seeing that the majority of our audience today chose the second option, when an incubator stays within 1 degree of its set point for an hour. So the correct answer to this is standard temperature condition. It's achieved exactly after an hour of incubator staying within 1 degree of its set point. So that was the correct answer. So let's move on to the next slide we have in the presentation, and we will talk about it in a little bit more detail. So here's a visual of what is going on there in the incubator. So when an incubator is first turned on and temperature is set, let's say it's at, I don't know, 36 degrees, temperature mapped over time looks somewhat like this, with the y-axis representing temperature and then time continuing being on the x-axis. So when we first turn on an incubator for a test, it should be at room temperature or ambient temperature, the bottom left corner of the little scheme that we have here. So the time it takes for the incubator to warm up 11 degrees or 11 degrees above your starting ambient temperature is called warm-up time. So say my ambient temperature is 20 degrees Celsius. However long it takes my incubator to get to 31 degrees is considered my warm-up time. So once an incubator warm-up time is set, and by the way, the warm-up time is set in the manufacturer's manual. And it is very important to note here that, and we will touch on that later on in the presentation today, that the warm-up time must be measured. It needs to be measured to make sure that it is within about 20% range of the time that is listed in the manufacturer's manual. And here is why it is important to do that. So when a baby is being admitted to an incubator, the nurses or clinical staff will turn on the incubator and have it warmed up and ready for the infant to be placed inside of it. So if the manufacturer's manual states that it takes 25 minutes for the incubator to warm up, then indeed the nurses, the staff, the little patient that goes inside in the incubator will expect that incubator to be warmed up at the end of those 25 minutes. And if it is not warmed up in this time, the consequences for that little patient can be very, very dangerous and even fatal at times. And that is why we need to, as biomeds, we need to measure that warm-up time and make sure that is correct or within the acceptable range. So after the incubator goes through its warm-up time and it reaches its set point, it actually goes into overshoot and then undershoot. And then after that, it oscillates in small temperature variations, resulting in an average incubator temperature that you see at the very right side of the slide. So when we think about the acceptable ranges that an incubator overshoots or undershoots, as pointed in the little diagram here, we must remember how fragile the infants are that go into the incubator. So according to the standards, for example, the IEC 60601-2-19, and we will discuss standards in greater detail in just a few moments. So that particular standard for incubator testing suggests that the overshoot should not be more than 2 degrees Celsius, which may not seem like a lot, but please remember again how sensitive and fragile those premature and sick infants are. So no more than 2% over the set temperature as an overshoot is what is acceptable. So once the incubator has gone through all of these minor temperature oscillations, kind of the picture here, with the temperature varying no more than 1 degree for 1 hour, that's when the incubator reaches that condition that is called STC, or steady temperature condition. So with that, I would like to actually switch on to the next slide and discuss the importance of the concept of STC. So once the incubator achieves STC, its most important function then is to keep a uniform environment in all parts of the chamber that Michael was telling us about. Temperature should be the same in all parts of the cabinet. Humidity and oxygen should be at appropriate levels and stay constant. The airflow above the mattress should not exceed 0.35 meters per second, and it should stay relatively constant to help circulate temperature, humidity, and oxygen, and ensure that all parameters are consistent throughout the cabinet. The incubator also helps minimize sound and vibrations. Below 60 decibel adjusted is acceptable for this infant's tiny and fragile ears. There are still alarms on the machine. They're both visual and audible. They are loud enough to alert attention to the incubator in case of emergency, but they're low enough as to not harm the baby's ears. So with that, I would like to turn it over to Michael again to dive into the importance of testing infant incubators and all of these parameters that we just talked about.
Yeah, thank you. As you can see, it's the incubator is much more than just a temperature-controlled environment that many people might think. There's a lot that goes into it in terms of humidity, oxygen, airflow, sound, vibration. There's a lot going on. So in this next section, Katya kind of touched on a little bit about why it's important to test this neonatal equipment. And I did reference that study earlier that called out some faults in such medical equipment, but I want to jump into a little bit more detail. So that the first slide we're going to jump into is on incubator testing standards. And with how fragile these infants are, it becomes pretty obvious that testing all parameters and testing them appropriately and according to the standards and or manufacturing guidelines is absolutely critical. The International Electrotechnical Commission, or the IEC, they make standards that best reflect the experience of the industry, the experience of researchers, consumers, and regulators worldwide. And they define those into standards. and they help establish uniform and universal testing procedures for biomedical service and design engineers to use. And they're critical in helping properly assess the safety of medical devices and ensuring patient safety. And that's really the purpose of the IEC. The other thing is most local, national, or even country-specific standards have been harmonized to those IEC standards, which are recognized as the international preferred practice. So the standard that we're going to focus on is the IEC 60601-2-19 standard. This recommends basic safety and essential performance requirements that are specific to infant incubator testing. So again, this is the standard we'll be focusing on today. So on the next slide, I wanted to kind of jump through kind of where these standards come from. Testing standards and regulations go hand in hand, especially when we consider why it's important to test and verify the performance of incubators. We talked about the IEC, but other players in this space are the FDA or ministries of health, and they help regulate medical device manufacturing, medical device sales, and ongoing safety review within a certain country. So the FDA in the US and ministries of health outside of the US. And they also approve incubator designs that can be sold in the USA or in specific countries based off of the data that they collect when following the prescribed tests in those IEC standards for incubators. So many, if not most, manufacturers base their specifications and their testing procedures around the standards. And from them comes the manufacturer's service manual. So a manufacturer's service manual will contain procedures that are specific to the maintenance and performance of that device and typically recommend an inspection frequency. While these testing workflows tend not to be quite as thorough as the standards, each manufacturer has applied the standards to determine the best testing for the design of their brand and model of infant incubator. So it's always a subset of the standard that's relevant. The manufacturer's service manual will give model-specific directions to test the incubator, such as the need to ensure warning lights turn on when they should. So for example, that's when the temperature is too high, an alarm should sound and light should go off. That might not be common across all brands and models of infant incubator. The other thing is who uses these service manuals. So we have various customers of our products, but independent service organizations use these, biomeds use these in hospitals, local insurance and corporate requirements also frequently conform and require compliance with these standards. And then there's the Joint Commission, JC, or DNV, right, Det Norske Veritas. They audit and accredit hospitals, including the biomed departments. So the medical device testing accreditation is based on the hospital's medical device management plan, and testing is to be based upon the manufacturer's recommendations unless other independent objective evidence shows alternate testing is effective. So an example of that might be an AEM test procedure, an alternate equipment maintenance. So really, if you think about it, all of the testing that you guys on the call today do circulates all the way back to the standards. So the standards kind of get built into the manufacturer's service manuals, and then those service manuals are what we use when we're doing preventive maintenance on these devices. So again, that's kind of how everything stems back to the standards. Everybody has a hand in this, but really at the end of the day, we are testing to those standards based off of the recommendations of the medical device OEM. So the next slide will kind of touch on what goes wrong, right? So I want to start with the question, why is testing important? We've mentioned multiple times how fragile these newborn or premature or even sick infants are. But what can happen when a parameter isn't in the acceptable range when it should be? What happens if the temperature is out of whack? What happens when humidity is out of tolerance, airflow, sound, I want to go through a couple of examples that will help better illustrate what can go wrong when one of these parameters isn't where it should be. So we'll start with temperature. In general, a premature baby can't modulate its own temperature. So if the infant is too cold, it can result in hypothermia, meaning shivering, hypoglycemia, and the depletion of glycogen stores. This means that the baby is actually using all of its energy that it should be using on growing, healing, and developing on just trying to stay warm. Another common side effect is apnea, meaning the infant stops breathing in its sleep. This leads to oxygen deprivation. And oxygen deprivation can actually result in brain damage in an extreme state, right? And it really doesn't take long to get to that point. And there's also some other issues from temperature as well. Hyperthermia is when the baby is actually too hot. And dehydration and cerebral damage can happen when the baby is on the low end of hyperthermia. Severe cases often result in heat stroke and even death. So again, temperature in both directions, too much and too little, can really have an effect on these patients. Sound is another parameter that needs to be measured. So loud noises, both from the operation of the incubator as well as background noises, can lead to intracranial pressure and even ear damage. So sound is something that needs to be controlled. Humidity. It's important for the respiratory care of the infant. The humid air helps the baby to breathe and for oxygen to be exchanged into the blood, as well as CO2 out of the body at a cellular level. So when a higher humidity is set in the incubator along with constant heat, infant heat and water loss are reduced. So it is important to make sure that the air is humid and not too dry. Airflow. Airflow helps circulate warm air throughout the cabin of the incubator. But high air velocities often result in evaporative water and heat loss for the patient. So making sure you're in that range is critical for those patients. Again, how it ties back to humidity and temperature. And oxygen. We have low oxygen concentration that can cause brain damage. And a high oxygen concentration may actually cause premature retinopathy, which can lead to permanent eye and vision damage or even blindness. So again, oxygen can have a huge effects on infants' eyesight. And these are just a few examples, and they can all result in dire consequences for the patient. We're talking about lifelong disabilities and in some cases even death. So testing incubators completely and properly to make sure they're performing the way that they should be and that environmental parameters are in a safe range becomes essential in helping protect the safety of the patient. Another thing that's desirable is shortening the time the patient spends in the incubator. And this is helpful for everyone involved. The cost of care for hospitals is quite high, not only due to the time, but also the energy that the nurses and clinical staff use in the pursuit of the well-being of the patient. And this can be immense and oftentimes overwhelming. And as a parent, right, having a child in the neonatal unit is emotionally and financially draining. So reducing the time that patients spend in an incubator is really desirable for everyone. And if we can test incubators and help ensure that they're functioning the way that they should be, we can help eliminate any time that's spent in the unit due to faulty performance of the incubator and needing to spend more time than they need to. So with that, I'll stop tugging on your heartstrings. And I think we will want to consider some other perspectives and reasons for why testing incubators and doing so thoroughly is so important.
All right, so yeah, so now that we covered the dire consequences of incubators working in in a not acceptable way, both that and the standards that actually require that testing, let's dive into the best practices of testing those infant incubators and discuss kind of what we have to offer as Flick Biomedical. So as we talked about throughout this webinar, an infant's first few days of life can be their most critical, right? So with that, we would like to make a point that it is important to routinely test and verify the safety and performance of infant incubators, and adopt a consistent inspection frequency for those incubators. You can check the manufacturer's service manual of the incubator for the frequency recommendations and see what they suggest there. The FDA, along with most manufacturers, recommends a minimum inspection frequency of once per year for the incubators. If you attended any other Empower Series webinars by Fluke Biomedical, you may have already heard us talk about having a consistent inspection frequency for all of your medical devices in the facility, and about how to determine that frequency if you haven't done so yet. We cannot stress it enough how important it is for the success of your MDQA program to establish that frequency. And let me discuss it today as well to kind of walk you through the process that you can go through if that manufacturer service manual is not available to you, or any other resources. Sometimes those manufacturer service manuals will give a recommendation on the frequency of tests for an incubator or other device under test, but sometimes they will tell you to check with the local standards. So there are also cases when none of that is available to you, but you must determine testing frequency for your incubators in the facility. So how would you do that? How do you approach that? So a great method for determining how often a medical device should be tested is a risk-based method. This is what we typically recommend to to our audiences. So the example that you can see on this slide is exactly what I'm talking about, that risk-based method, that evaluation that helps you determine that frequency of test. This particular one is done by the University of Vermont's Biomedical Engineering Department, and it is described in the Medical Equipment Quality Assurance book written by Toby Clark, which is a great and accurate way to determine the frequency of test. We very often get questions on how to get access to this book and to this particular evaluation method. So the great news is that we have the content of this book, including this particular method, for you absolutely free in our Advantage Training portal. If you haven't already done so, you can find that portal if you go to flukebiomedical.com, you click on Knowledge Center. We talked about it before. And then I think the top link that you will see there will be Advantage Training. So the education is absolutely free. All the resources are available to you at any time, 24/7. You can go in and explore this particular part of the, setting up your MDQA program and complete this assessment for your medical devices, including the incubators. So once you determine the inspection frequency in your facility for your medical device, in this case, an incubator, the testing frequency that you believe to be appropriate for your equipment, for your facility, for your patients, please be sure to have a written statement with the justification for that particular frequency documented. This statement of policy will come in handy during audits of your quality assurance program. That's why we recommend doing so. Let's switch on to the next slide and continue the discussion of the inspection frequency. So here we have an outline of the typical checks that need to be performed on an infant incubator. Usually you will do all of that performance inspection per the standards and/or the manufacturer's recommendations. These checks will often include either weekly or after each patient checks, quarterly checks in some cases, like for example, replacing air filters. There will be those annual PM schedules that we talked about in the previous slide, and then you will sometimes, or oftentimes, have the battery replacement and calibrating the humidifier. Like those typically come at the 2-year or 3-year mark, which are also important to do. All right, so with that, let's switch on to our poll question number 3.
Yeah, so we've reached the third poll question of our webinar. So in general, the question is, how many places do you currently measure temperature inside an incubator? Do you do it in one spot or just do a spot check? Do you do it in 2 to 4 spots, or do you do it in 5 or more spots?
Let's see how diligent the procedure is for our audience.
And the responses are coming in. Let's see, we'll give
Nice.
attendees another 10 seconds before we close the poll. Okay. And the poll is now closing. We'll share the results. So 1% indicated 1 or spot check, 62% indicated 2 to 4, and 32% indicated 5 or more.
All
I'd like
right.
to
Well,
see those results. Yeah.
yeah. So I won't give you the answers right away, but I will jump to the next slide to give you the answer. So probe placement in general when testing all these parameters, especially temperature and airflow, are really important. And there are common misunderstandings when testing and performing preventive maintenance on infant incubators when it comes to this. So sensors for all of your parameters, including temperature, humidity, airflow, and sound, should be 10 centimeters above the mattress, which is approximately the height of an infant when they're laying flat on the mattress in the incubator. And in terms of numbers, I think you can see from the image that we're looking for 5 sensors, right, placed at a specific height. So to jump into temperature, which is air convection temperature, I just want to share. And the other thing is airflow. All of those should be measured in those 5 locations inside the incubator. So capturing the temperature in a single location is not acceptable. And this should make sense as an infant's torso and limbs may be stretched across more than just the very center of the mattress. Or you might only be getting the temperature of what the baby's hand might be experiencing while missing what their foot on the other side of their body might be experiencing. So we really need to ensure that the environmental conditions are uniform across the entire chamber. Maintaining an infant's core and skin temperature is absolutely critical, as I've said before. And as we think back to how an incubator functions, you have a motorized fan that circulates heated air throughout the chamber of the incubator. And heat loss from the infant by convection is dependent upon that air speed and that air temperature. So by measuring both the temperature and the airflow of the incubator in more than one location, you'll get a really good insight into the actual performance of the medical device. And you'll be ensuring the uniformity of those environmental parameters throughout the entire incubator. So think about it this way. If we were to divide the mattress into 4 equal quadrants, a temperature and airway probe should be placed in the very center of the mattress, which in the image here is point M, and also in the center of each quadrant that we just created. So A, B, C, and D. And the other thing to note is that the pattern of airflow does differ in every model of incubator. So it is really important to be familiar with the direction of airflow inside the model of incubator you're testing, and make sure that you're placing the airflow probe properly to obtain an accurate measurement. So think about where those fans are, get a sense for how the air flows, and make minor adjustments based off of that. But in general, the goal here is to make sure that you're ensuring that the entire environment is uniform in terms of the parameters that you're testing. Okay, so I want to bring you back on the next slide to the diagram that Katya walked you through about STC. So you'll remember this from earlier today. And this shows the warm-up time, the overshoot, and the oscillation to a steady temperature condition. Manufacturers' manuals will specify what that warm-up time is or should be. And testing should be carried out to ensure that the incubator is within the acceptable range of 20% of the specified warm-up time. The other thing is the temperature overshoot, right? That should be no more than 2 degrees Celsius above the set point. Some other things about STC that I want you to remember is that, one, it stands for steady temperature condition. And it's achieved when the incubator temperature does not vary by more than 1 degree Celsius over the period of 1 hour. So that's the definition of STC. So again, think about, just remember those, the warm-up time, the overshoot, and the definition of STC. Simultaneously measuring each parameter during warm-up time and after STC helps give us insight into how the device is running as a whole, right? And where problems might be occurring if the incubator isn't functioning properly. So it gives you a sense for, is it something with the fan? Is it something with the heating element? You can start to troubleshoot by looking at those results. And the other thing to keep in mind is every time a porthole on the side or the cabin door or hood at the top is opened, STC is lost, right? And then you have to achieve it again. So STC being the same temperature, not varying within 1 degree Celsius over a period of an hour. So you really want to have that condition undisturbed. So just keep note that opening those doors and hoods does have an effect on that. Okay, so in terms of performance inspection tests, this is another kind of obvious best practice, but it's to perform all the tests necessary to ensure proper performance. A complete list of tests and criteria can be found in that IEC standard, right, 60601-2-19, or in the manufacturer's service manual. But I want to walk you through the basics. So in terms of temperature, you want to make sure that your incubator warms up in the time specified in the manufacturer's manual. You want to test to ensure that the overshoot temperature doesn't exceed 2 degrees Celsius of the set point. You want to check all surfaces that might touch the infant and make sure that they do not get too hot. You want to test to determine when the incubator's temperature stabilizes and stays at that temperature setting for at least an hour, right? So there's your STC. You want to verify the temperature is uniform and the same throughout the compartment, not just at one test point. You want to check the accuracy of the temperature indicator itself. And you want to make sure that the temperature control sets the temperature to the correct value. There's also a skin temperature sensor with, and you want to test that with a calibrated heater assembly. And you want to test to ensure that the temperature control is the actual temperature sensed by the skin temperature probe. So one big parameter here is temperature, and there's a lot to go through when you're testing it. So do refer to either the standard or the manufacturer's service manual. In terms of humidity, you want to check the accuracy of the relative humidity. It should be within 10% of what the tester indicates. For airflow, you want to measure the air velocity inside the incubator compartment to ensure that it's at or below 0.35 meters per second, again, at each location. For sound, you want to determine if the sound level inside the incubator compartment is below 60 decibels. Inside and outside alarm levels should also be measured to ensure that they are within a safe range. And you want them to be audible over any background noise, since it's oftentimes not only the incubator that's in this room. In terms of oxygen, again, you want to check oxygen concentration to validate that it is within the acceptable range. And you want to ensure that the visual and auditory alarms are appropriately activated. I kind of talked about how those are specific to brands and models, but I did want to kind of note that here as well. And along with providing oxygen-controlled environments, many incubators also contain built-in SpO2 blood oxygen saturation, so pulse oximeters, and monitoring systems. And these are part of the testing and preventive maintenance for incubators as well. So remember to test the entire system, not just the incubator itself. And then there's the weighing scale. So most incubators double as weighing scales. So make sure you're measuring the scale and using a series of calibrated weights to ensure that it is accurate as well, since the nurses and clinicians use that function as well. So think about the entire system. And the other thing to note is electrical safety. So most manufacturer performance inspection procedures require an electrical safety test, which includes ground wire resistance and chassis leakage. So keep an electrical safety analyzer like the Fluke Biomedical ESA 612 close by to complete the electrical safety portion of the performance inspection easily. While some people treat the electrical safety and other integrated device testing as separate workflows, they're generally treated by the manufacturer and standards as a single series of work and measurements that all lead to one overall test result file and report. So again, just take a little zoom out, think about all the things that are being used to treat this patient. And anything that's in that system should be tested and should be contained in one test report. So I would urge you to think more broadly. And with that, I want to toss it over to Katya to point out some tools.
Yeah, so here I would like to discuss the importance of choosing the test equipment, that will be right for you and kind of answer the needs that you have when testing the incubator and the environment around it, and the equipment that you can rely on for doing the right job for you. So we're suggesting that you need to use separate equipment other than the self-test function, because as specified by regulatory bodies such as the FDA, independent objective evidence is required. So when choosing your instrument, one thing that we would like to kind of advise here is that you need to pay attention to metrology, and metrology matters. And I would like to give you an example of kind of what I mean by that. Example is very simple. When you go to a gas station to get a gallon of gas, how do you know that you're really getting a gallon of gas for the price at which it is posted? And so you know that because of metrology. Metrology is, basically the science of measurement and its application, and it is especially important within medical device quality assurance, and it matters to us as biomeds, right? And why does it matter to us as biomeds? It is because of the many things that it ensures for us, as we go through the testing. One of them being safety, right? So we depend on measurements for medical electrical safety and minimum performance standards that we keep discussing. The other one is legal requirements. So manufacturers and hospitals have a legal responsibility to keep records to show that medical devices and test instruments that are used at the facility to evaluate those medical devices are accurate and traceable. The other one is interoperability. So measurement parameters for medical devices that are manufactured, let's say in Asia, should be absolutely correlated to the measurements performed in the US. Next one is traceability. So interoperability, that I just mentioned, depends on all measurements being traceable to a single reference point. And finally, we have consistency and quality. So we want to remain consistent in order to build and test products with quality. So those are all the aspects that metrology ensures for a medical device. That's why we're suggesting that when choosing a toolkit to perform a full medical assurance procedure on your infant incubator or any other medical device, make sure that you get equipped with analyzers and simulators that are backed by world-class metrology. That is the best practice here. With that, let's move on to the next component, the next best practice that we have for you today. So one more thing that we typically recommend is something that contributes to a successful testing process when it comes to infant incubators, and that is test automation. The reason for that is that test automation can help reduce test time and increase efficiency of your performance. Testing each parameter one by one when it comes to incubators or using individual handheld tools can take a very large amount of time. But if you use an analyzer with built-in test automation, that test time can be dramatically reduced. All you need to do is set up the device and start testing, and then you're free to perform other work if you need to. Other benefits of using test automation to validate the performance and safety of incubators are data traceability that I will touch on in just a moment, simplified data extraction for reporting, and reduce human error. So all around, great solution. One more reason that we recommend using test automation is because it helps with your reporting efforts, and that is what I just mentioned. You probably already know that test results should always be archived, right? So the purpose of testing and producing those test results is to have a continuous stream of data that is showing all changes in the safety and performance of the incubator year over year. Long-term trending of this statistically relevant information provides us the basis for predictive maintenance. What we mean by predictive maintenance is you actually know when the next repair is most likely to happen, and so that the parts, especially those that have very long lead time or very costly parts, they can be ordered and received just in time for the upcoming repair event. Why is this important, or why is this something to pay attention to? Because this saves money to the facility and increases the amount of time that the medical device is available to use. This actually goes back to the point that Michael was making in this presentation earlier about how a longer stay for the patient is both costly for the family and the hospital. So ensuring that the incubator is operating properly and can be repaired in a timely fashion is extremely important for all of the parties that are involved in the process. And test automation with that continuous stream of test results that is allowing for predictive maintenance is allowing you to do so. That is why we recommend taking all of those steps when it comes to your test procedure around the infant incubators. And I think with that, actually, our presentation time is over. So we would like to thank everyone who stayed here throughout the presentation itself. We're going to dive into the Q&A now and see if we have any questions. All right. Dun, dun, dun. Okay, so I'm seeing a question about the difference between temperature probes and temperature pucks. That is something that we discussed today. Michael, would you like to take that question, or would you like me to answer?
You can kick it off and then I'll jump in.
All right, so I guess the basic difference between the probes and the pucks is kind of the environment that they're being used in. So probes, you want to use them in an enclosed environment. For example, a transport incubator, because the probes are very sensitive to the environment around them. And so if that environment is affected by something, let's say an incubator, like the cabin is open, those readings will not be accurate. At the same time, the pucks are designed in a way that they allow for absorbing like the heat, for example, from the device or any other environment changes. And that is why they will be still providing accurate readings when it comes to even, in the external ear movement or something like that. I hope that answers the question.
Yeah, I think just a slight edit to that. I think the pucks are also really useful for radiant warmers.
Yeah.
So if you're using a radiant warmer, that's where you want to really put a puck. in use. And then, yeah, your probes can be used for an incubator or transport incubator.
Correct. Yes, thank you. Next question. What is the optimum parameters for all such as temperature, sound, humidity, airflow, and oxygen concentration rate? So I believe that we answered that question, and I think this question came in at about kind of a half of the presentation. So I do believe that we covered that. We had a slide with all the performance inspection tests. Maybe we could revert back to it. I think it's kind of 3 slides back. Maybe you display it on the screen again for everyone to see. Maybe take screenshots if needed.
Yeah, and I think there is no optimum per se, right? It changes for every brand and model of incubator, but there are some things that are written in the standard that all incubators need to follow. So it's just important to note that you do follow the brand and model specific guidelines, just to account for any changes that might occur between any incubators that you might be using. So do always use that as the source of truth. And again, what we provided here were kind of general guidelines derived from the standards, but do note that they can change between brands and models. So yeah, there is no one source of truth.
Yeah, I'm not sure who's driving the presentation. I wanted to get to slide 25. I think we had all of those measurements up there. Yep, this one. Yeah, so let's maybe keep it on the screen for a couple of minutes for everyone to take a screenshot if needed. Let's move on to the next question. The next question is, can the temperature probes or pucks be plugged into different ports? Can they be interchanged between different devices? And I think this is a question about the Fluke Biomedical incubator tester, the INQ2.
I would think so, yeah. And I don't believe that they can be used if you're thinking about using them concurrently. I believe you should either plug in the temperature puck or the temperature sensor probe to the temperature port. So you can't have both at the same time, I do not believe.
Also, yes, so that is correct. And also, the pucks and the probes are calibrated to its respective port. So it is critical to use them together, not have them interchanged between multiple tools. If you do need to replace a probe, let's say, you will have to use calibration numbers when you set up your INQ. You will have the menu items called probe information under setup, so you will have to do that. But in short, no, you cannot plug them into different ports or use with a different INQ that it came with. Okay, let's see if we have more questions here. Yes, we have a few more. What is the meaning of the numbers on the inspection frequency slide? Let's go back to that slide and let's take a look.
Yeah, so in general, there are a couple sections on here, but it's just you are going to set a score for your either facilities experience or the industry's experience, whatever it might be, across these categories in the gray bar, right? So in terms of clinical function, how is it being used? If it's used for life support, you're going to have to test it more frequently than if there's no patient contact. Similarly, for physical risk, if it could cause death, you're going to weight that more heavily versus if there's no risk. So we do similar things for problem avoidance, incident history, and the manufacturer's requirements. So it's a mix of your, and this is what you use if you don't have an inspection frequency given to you in the inspection in the user manual. This could also be a sanity check to say, am I testing enough, right? So again, maybe this makes you rethink how you test, but essentially for an incubator, you get back a score of 14, which would infer that you should test them twice a year. That should be your frequency. So if this comes in more than your user manual, then maybe you might want to think about maybe testing more frequently than you are today. But you can always lean back on the user manual to say that you only have to test it once a year. So it's a guideline, and it's meant to help you.
Yes, and yeah, that was a really great description. I just wanted to quickly comment that we only have one image from that book that we referenced before. What is not included in the slide, but it is available in the book and the advantage training, is kind of the reference chart. So let's say we got 14 for the incubators. There will be a chart that will tell you, what 14 means. And in this case, it means, twice a year. So you'll be able to see all of that if you go to flukebiomedical.com, Knowledge Center, and then Advantage Training. I'm being notified that we're at time. So thank you all very much for being here with us today, learning more, hopefully, about neonatal testing from us. And we will see you at the next Empower webinar.
Thank you, everyone, for joining.